Okay, so at AI Camp Meetup, I tried to record it myself. Probably should need some help there, but I got some of myself talking and some of the audio. Let's see. Let's see if we can get as much as we can. Mix it together with the slides, and it should be a little better than just the myself with none of the slides or demo. But we'll do what we can, and maybe I'll have to re-record it from scratch. But give you some of the live experience. We'll see how it goes. Let's see.
Is it open? Is it on? Oops. Try talking.
Test, test, test.
Is that on here?
Okay. I'm very happy people came out in this heat. It's just very hot out. Much nicer in here. I've got stickers in the back there. There's cats on them. You might want them. If you ask a question, you get a weird bird. That's our bird. I don't know why we have a bird. That's actually the name of the database is Milvus, and Milvus is a small predatory bird. I don't know why that's a good name for a vector database, but that's what it is. If you don't want to follow these slides, just grab them now, and you can take a nap or grab something to eat, just in case. Save you time there. Or you can download them right away. I think we got everyone on the slides. I'm trying not to show too many slides. I'll show you a little bit of demo as long as the internet gods are with us today and it's not too hot. On the way here, the highway was on fire. They closed the trains in Secaucus, and so I had to drive in. So I really wanted to be here. So at 90 degrees, I was having second thoughts. I'm going to change my title to AI advocate because that sounds much better. I think I could get more money with that. I don't know what I was thinking. Developer doesn't sound expensive. So we're going to cover a couple of things here. If things are too easy, just give me that look and like you're sleeping and we'll go past them. If they're hard, we'll try to slow down. I've got New York speed, even though I'm from Jersey, so if I'm going too fast, throw something, preferably light, not dominoes. Then we're going to cover vectors. We were having a nice discussion in the front on vectors. Kind of cool now that all the models like them. Trying to see if I'm louder. I don't know. Okay, and then talk about Milvus, which is an open source vector database that everyone could start using pretty easily. Either you could use it right in a notebook, runs in local database like SQLite, or you can run it in Docker, or you can run a full-fledged cloud instance, which is a very distributed architecture, but we have some people in the community that are running databases with zillions of vectors, which is ridiculous number. Maybe just billions. But we've been around since 2017 in the open source. And I think we're going to get bigger because there's a lot of data to put in there. When you think of data before, it was rows, columns, which is still awesome data, and you still need that, but we could store that along with the other data. But now with all these models, it makes a lot of sense to be able to have text, images, video, audio, anything that makes sense. We've got a number of people in pharma that are using this to store 3D models of molecules, and they're running these against GenAI to come up with novel compounds and new drugs, and being able to grab stuff and just move it around and then just store it and save it, find things that are similar and have that happen sub-second, pretty nice. It's also nice if you want to do something simple like a chatbot. But, traditional database, you type something in and they match it, which is great if I want something and I can put the exact words in, works really good. But that's not always the case. Sometimes I want an apple. But an apple could be food, it could also be the laptop I'm using. You know, it's a lot of things, so you have to know what it means. Like, what do you want? Did you want an apple, and we can get that from context? Or do you want the, you know, those words? So that's kind of important, and that's kind of missed unless you do some really weird coding in a regular database. But with vectorization, which is really picked up now that everyone has a deep learning model and everyone's doing large language models, you know, you're taking these, and these will build up these vectors very quickly. Previously, trying to do this was slow, and there wasn't a lot of stuff, but now they've been churning out these models, so there's so many options on how you turn whatever your data is into something that can be stored easily, found easily, and used by lots of different algorithms, lots of different systems natively, which is really nice. Again, we talked about it, lots of data. Now, we couldn't have done this unless things that have happened recently came to pass. There's been a number of important things that have happened over the last 10, 20 years. You know, as being able to take data, especially text, natural language processing, NLP has been a big area of research for a while. Stanford had a great library, and they were doing the basics of getting stuff so you could understand text. And being able to do that was huge. And then we started to get the models that could classify images. So once that started to happen, we're starting to build up some of the things we need there. Then with Word2Vec came out, and a number of different models that made it very quickly able to make these embeddings so that you have these dimensional vectors that can be easily used for search and for near neighbors and finding where things are. And then a ton of new stuff came, like BERT from Google, and a number of these other ones that really made this analysis of unstructured data useful, fast, and very interesting, and a lot more accurate. Obviously, we've got a long way to go before we get to, you know, 90, 100% accuracy for all these things, but, you know, wasn't that long ago where if you got 50 or 60, you were amazing, and those numbers keep going up. I'm imagining maybe someone in this room is studying that now, and in 5 years we may be, you know, a lot more exact matches there. So, so you need a new database to help this out. Now, it's nice to store things in a file somewhere, but you'll soon see you have a lot of files. People want to find them, they want to search them, they want to use them in different libraries and applications. And also, as soon as you get corporate people involved, they want security, I want RBAC, I want governance, I need 24/7 support, I need different areas where people have things stored, I need people to have access to one thing or another, and they're going to want to put their entire corporate database in there because I can put logs, emails, texts, you know, documents. Now, every image you've ever taken, as you can imagine, people like Facebook have been doing this a lot because they have a lot of this data. And it doesn't make sense to store that in a relational database. So they've been key in writing some of these algorithms that we use in Milvus. And one of their engineers came over to work full-time on the project. But it's also just a part of the same thing there. And the thing you'll see is, corporate, you can't just have a couple little databases. They start going into petabytes, billions of vectors, because every image, and then you want to break things up different way, and they need it to come back quickly. If you went to Facebook and you tried to do a match and it took you 5 minutes, you're probably not using Facebook anymore. So unfortunately for the world of enterprise, you're held to the same standards as the largest internet corporations in the world. If you don't get your data back sub-second, people are going to be very upset there. This is a demo I'll show you, and you could go there yourself. We have this running for everyone. This is just an example of what I think is pretty cool, because I like cats, but it's for any image. The demo is upload an image, and it searches a vector database for similar items. And what's cool is I put an image to search and search images. I mean, I'm not Google. This is just, this is just running in a Docker container. You can run your own image search, without any hefty database or any hefty learning. And if you want to play with it, it's online. Obviously, it's going to be searching a standard list of images. What's nice is you can start building your own. And you think of the applications, you want to use it as a security system. What's nice as well is you don't just have to search by one thing, not just an image or text. You can have additional fields with that. So if I know you come in with a badge, I get your face, but I also have your badge ID so I can match it up. So I know additionally who you are for certain, not just approximate. And then I can take that other data and use it for applications down the line. So, as you're walking through the building, maybe the lights will go on because I know where you're going. Yeah, it could be creepy, but you got to, we have those skills. What applications you build, we'll have to see. But how do these databases work? Unfortunately, there's a lot of math, so I don't really like to go into it because it just gets really boring unless you're a math major. If we have any math majors who want to go real deep into this, no one probably wants to listen to it, but it's very important, but does work. And what's cool is there's a tiny link here. So if you downloaded it, you can go there and there's a little more explanation of how these work. But it's pretty cool for text is having the things that are near it. So obviously a queen and a king are related. So is a man and a woman. So is a queen and a woman. So you get how much distance there is between them. So when we're trying to find matches for stuff, you can see how you're going to rank them and rank them on different features. That's why you can have typical for images will do 500, 1,000 different dimensions. And what's nice about this is someone has been doing this math for a long time, so there's a lot of different ways to get this similarity. One of them is L2. That one's usually the default we use for text. Euclidean is doing that math. As you start seeing this and you go, well, how many of these do you have to calculate? And then you see why some people are using specialized hardware, GPUs, because running all this math is kind of what they were doing in Doom and Quake and those old video games, because they were storing things in pre-calculated large arrays to represent images and things that move. Doing this floating point math is complex, but the hardware we have now, especially if you've got NVIDIA, is pretty fast. And we've seen it's gotten faster with things that have come up, inner product, another one. Again, more fun math. Everyone likes to see math times. Cosine, I'm like, I did that in college and I thought it was useless. Well, the computer needs it for something. Fortunately, to use the database and to use this, you don't have to calculate any of this unless you are writing your own stuff. And I don't know anyone who's doing this. If you're deep embedding and writing your own models, even below that level, so not too many people have to do this math. But it's nice to know someone did it. It really works. If you're going for your doctorate, maybe you want to prove some of these. I think most of these have been proved for a very long time. But if you put the word AI in your PhD talk and just do some math, you could probably get away with it and get a degree and no one will know, because who's checking that? It's real smart people who go, okay, you want to do math and call it AI. I mean, that's pretty much it. So can't we store this stuff somewhere else? And everyone's been saying that since 1960. Every time someone releases a new thing, they're like, well, we did that before. I could store this in a flat file. I could store it in a B tree. I could store it in a simple index. I could store it in a relational database. Yeah, you can store things in a lot of places, but there's places where it was designed to run it, designed to store it, and makes it faster, easier, and handles things that they didn't want to do. Like if I wrote my database already and it works, if I start playing around with it to add all this weird data, could damage what you have already, or just, it's not designed for that. Like, I can pick up everything I want from Home Depot in a tiny little car, in a little smart car, but how's that lumber fitting on there? Or maybe I could strap it to the roof and hope I get it home, but maybe you need a pickup truck for this. This database is the pickup truck because it's designed to do this. It's not designed to do relational data. It's not designed for doing ACID transactions. It is designed to support these things that are related to vectors. And trying to run all this computational stuff for people who are used to just having a lot of storage and maybe some simple indexing, eventually once you get past the demo use case, then you're going to have problems. And I've seen this because a lot of companies will start off and they're like, I have 5 PDFs. I can store that anywhere and still get okay results. And then they're like, well, now I have 100. Because someone's going to be successful. And people are like, well, go through every email we have at the company. And then you're like, oh, now I've got 100 terabytes of data. I can't put this in a little teeny relational database and have it not catch fire. So then you go, well, why don't I use a library? I know how to code. I'll use Facebook C++ library and hand code everything. That'll be great. Well, if you could do that, that's awesome. But you're manually writing this stuff and it doesn't have things like filtering. So you can do your vector search, but you can't add any extra filtering metadata. You can't add different types of indexing. And things could go crazy. I mean, you could get stuff that's not out of the right libraries. You can't scale it. It's running on, one node. And then how do you get it shared it? How do you give an interface? Probably not the best unless you're, again, maybe working on that PhD. But if you want to use an open source database that was designed for this, and that's been running for a number of years in pretty large production, Milvus has all this and was built just to do indexes on vector data. It wasn't designed for relational data or JSON or some other stuff. Designed for this. It was built from some people at a university. They needed to do it, and they needed a little more than a library because they wanted to be able to do backups, be able to migrate to other databases, to shard data out, because once you get bigger than a couple of nodes, how you're managing that data, how you're aggregating it together, how do you handle when data needs to be deleted or it needs to be updated, or you have 10,000 people using the database at the same time. Once you get successful, that happens. What happens when people release new, faster hardware? You want to take care of that and use that as well as possible right away. I mean, there's a lot of stuff like FPGAs and GPUs and SIMD formats that make this math faster and easier. So if you already have that hardware available, use it. And being able to do it more precisely, and again, billions of vectors in production at a lot of companies. And then being able to do other types of indexing. Like once you start going through this, you'll see that there's a lot of different ones, and some work well for text, some work well for images. How do you want to match them? A lot of this is how quickly do you want it? Do you want exact matches? Do you want close? There's trade-offs based on time, money, space. You got to make those trade-offs. I mean, you can make it exact match, but it is slow. So for most cases, you can get close to what you need, 90% matches, and then filter on some other attributes and get exactly what you want. And again, different ways to search is pretty nice to have here. So you get, give me the top 20 results that are nearest neighbor, do a range, work with sparse vectors, work with really densely packed ones, search across multiple vectors, group results back together. Again, the metadata filtering, which isn't in the libraries, so you could filter out like other attributes, and I'll show you an example, and being able to do different types of queries. there's an open source company that's putting a SQL interface over us because they can plug into some of these different search types. And again, having multi-tenancy, once you get past, a simple application, you're gonna have to do that. And again, different compute types based on what hardware you have, which there's a lot. And if you wanted to run in production, it's been scaled out, so you can scale out all the pieces you need. Different nodes for query, different for data, different for indexing. And then native storage down here in the object store, so it can be as big as it needs to be, which is nice. Supports Azure for the people in here. And Minio, I use it for Docker. But it keeps it in Kafka or Pulsar as it's being processed, so things can happen in a distributed manner and scale out across platforms. Again, if you're running on a notebook, you don't need all that. But once you start getting into the hundreds of thousands, millions of these items, you start to need a distributed architecture, as most people have found out with things like Spark and Flake and Hadoop and all these big architectures. It's hard to get bigger than a certain size and support a large number of queries, a large number of inserts without having a distributed architecture. And there's some people using it. Again, if you give me a star, I'll give you a sticker. I'll give you a sticker either way. There's a lot of kit stickers in the back. If someone asked a really good question, I can give you a weird stuffed animal. It is a very weird stuffed animal. So common use cases now, RAG to make your AI results better. Recommendation systems have been really big. Some really big retail people use it for that, because being able to find similar things based on a number of attributes, including images, search results, lots of stuff there. Being able to search text properly, matching images, matching video, matching audio, molecular, and the multimodal, which is getting to be really cool, is being able to search over a bunch of different types of things. And not caring what the input is, put an image in, get a video out, kind of cool. And what's nice is with the open source code, I write code, it could be Python, Java, Rust, Go, C#, a bunch of different languages. And I could start off running in a little teeny environment on a laptop against Milvus Lite, a little stored file, and then move it to Docker and Kubernetes and that giant architecture without having to change the code. So it's nice, you're not throwing that work away you did on your laptop. It's the same code. You take our free Helm chart, push that out into the very large space, And then we're friends with everybody. We work with all the open source and non-open source things. So if you're looking for, I want to use LangChain, I want to use LlamaIndex, we've already worked with them. And we're always working with more. Airbyte just put out a thing. If you work at one of those places and you don't have something to us, let us know. We definitely want to collaborate on getting data into and out of things, easily is always nice. We've got a Discord like everyone else. I kind of like Slack better, but I know Discord kind of gets blocked at some enterprises because people usually use that for playing video games, and that's kind of what I use it for too. So we could do that. This is my meetup. That's other events. I purposely make sure it's not on the same day, which sometimes these guys don't tell me too far in advance, so we try to figure that out, but I get an idea when you do it. We're doing a couple in July, a couple in August, and I also do one in Princeton. So if you want to speak, same thing, if you want to announce you're looking for a job or you have a job, definitely come out, reach for us. I'll show you some demos if things haven't crashed. We still have a little time, right?
6 minutes.
6 minutes. I guess that's enough time. Okay, so let's make sure. Big enough here. So this is, fortunately, as opposed to some other open source systems, we also have a GUI tool to let you search your data, manage your data, which is helpful. And it is, everything's a collection. You go into collections, gives you some of the things there. What's I didn't mention about Milvus is it has tunable levels of consistency. So if you don't care the data's not fully arrived yet, you can still run searches against it. It won't damage the data, but your results can change as the data comes in. That's up to you. Now we can search our data. Again, it is back instantly. This is images that there's a link to an article I have on using a Raspberry Pi with the new AI kit to do classification on a live camera. And as I'm doing this, I take a sampling of that and send those as vectors into Milvus to make it available for search. And like I said, you can do search, it's just matching a vector, but you can also do by other algorithms using some of the, remember that filtering? So I can filter on something like label, and again, that kind of makes sense for classification. So if I want to find only ones that look like a TV, then search on that. So it matched the vector similarity plus filtered on the label. Makes it a little easy for you. Now, what's an example application? Remember I said this one? So you can just go to this website, upload an image. I don't know they'll be able to match my weird image here. Oh, it tried. It is kind of a weird image. This is a picture of a small plastic cat next to the new Raspberry Pi. But yeah, you can try this on your own. You can upload any image and get weird results depending on what it is. Like that kind of makes sense because the background scene of this image is an AI generated city. So it found cities at night. Not bad. Again, this one you can play with, and if you want to try the GitHub repos there, you can just download it and run it in your own environment pretty easily. But this one, I like this demo because it's kind of fun and it's pretty easy. And if you've got cats, who finds cats? Oh, a bat. Oh, my cat's going to be upset he's a bat. This guy, my girl looks more like a cat, though. That's pretty close. Well, it is kind of hairy. Look at the size of this cat. Relatively close. How about my little cat? Oh, he matches pretty well. He is really cute. He shows up on some of the webinars, but I don't know if he's supposed to. We have an open source project out there called OSS Chat, and you can go there and it lets you chat with documentation of different open source projects, like Milvus, like other things. So you pick your project, and then once you're in a project, like say I wanted, it's gonna like, you wanna select Apache Kafka, and then you can switch to that, give me results. Based on the different ones it's been trained on, and we take suggestions if you have another project. I was running against Milvus, so I could switch to Kafka, and then it'll give me previous questions people asked. We found that to write a interactive chat, we found something that's important to save you money. We wrote an open source project called GPT Cache, which does intelligent caching, so we don't make 1 million calls against OpenAI, because we don't have that much funding, But what's nice is it also stores frequently asked questions, and it can retrieve those faster. But the source code for this is also available, so you can just download that as well. But just to show you some things running, pretty straightforward though. For additional resources, I got more cats. If you don't like cats, you're not going to like any of this stuff. Sorry. This is my latest article, came out yesterday. It's how to use the Raspberry Pi 5 with the AI kit to do classification and classify your images and send them into Milvus for later search and retrieval. And we saw that was sitting there in the vector store, and that runs off my little device there, but that can run off anything. Just to show you as an example, we could put that small, pretty easy to do. Another example is I grab all the street cameras in New York City live and then put them in the vector store, make them available for search. And what's nice is I can add all the metadata, so, you know, what street location, lat long, other things, and then pair that with other open data from Open Data New York. You know, match it to street crime, sales, weather, and, you know, find where you are. And don't clap.